At its peak, it was the largest civilization on Earth, larger than Mesopotamia, larger than ancient Egypt. It stretched across an area of roughly 1.5 million square kilometers, a domain so vast it dwarfs every empire we consider foundational to the human story. It built cities with indoor plumbing when the rest of the ancient world was drinking from rivers. It standardized weights and measures with a precision that modern metrologists still find remarkable. It traded with civilizations thousands of kilometers away. It developed a writing system that no one on Earth has yet managed to decode, and then it vanished. Not slowly, not in the way civilizations typically fade, through gradual conquest, through centuries of economic decline, through the slow grinding erosion that turns empires into dust. It vanished with a speed that archaeologists, even now, struggle to explain. Cities that housed tens of thousands of people were abandoned. Trade networks that spanned the ancient world went silent. A writing system used across an enormous geographic area simply stopped appearing on any surface. The people scattered into smaller settlements, into the countryside, into a silence so complete that for nearly 4,000 years almost no one even knew this civilization had existed. The Indus Valley Civilization, also called the Harappan civilization, also called, by some researchers, simply the Indus civilization. By any name, it is one of the most significant and most unsettling archaeological mysteries in the entire human record. Because we do not know what happened to it, we have theories, we have data, we have decades of excavation, remote sensing, isotopic analysis, and computational modeling. We have the physical remains of cities that were, by any measure, extraordinarily sophisticated. We have the bones of the people who lived in them, the tools they used, the seals they stamped into clay, the ornaments they wore, the drains they built beneath their streets. What we do not have is an answer, not a confirmed one, not one that the archaeological community has settled on with anything approaching consensus. The disappearance of the Indus Valley Civilization remains one of the deepest open questions in the study of human history. And the more carefully archaeologists look, the more unsettling the picture becomes. This is the story of a civilization that built something remarkable, lasted longer than Rome, and then disappeared so completely that its rediscovery in the 1920s shocked the world. And this is the story of what we still do not understand about how it ended. Part 1. The discovery of a lost world. The story begins not with an ancient city, but with a railway. In the 1850s, British engineers working on the East Indian Railway were constructing a line through what is now Pakistan in the province of Sindh. The project required enormous quantities of ballast, the crushed stone and rubble used to stabilize railway tracks. The engineers discovered, to their convenience, that the surrounding landscape was scattered with ancient fired bricks. Old bricks. Exceptionally well-made bricks, uniform in size and density, fired at high temperature, clearly the product of organized industrial production. The engineers used them. They loaded them onto carts and packed them beneath the railway tracks, unknowingly destroying remnants of one of the oldest urban civilizations in human history to build a colonial infrastructure project. Estimates suggest that over 160 kilometers of railway track between Karachi and Lahore were ballasted with bricks taken from the ruins of Harappa, a city that had been buried beneath the soil of Punjab for nearly 4,000 years. The bricks came to the attention of British archaeologist Alexander Cunningham, then serving as director of the Archaeological Survey of India. In 1872, Cunningham visited the site of Harappa, noted the unusual artifacts being recovered from the soil, including a small carved stone seal depicting an animal he could not identify, and recorded his observations. He suspected the site was old, older perhaps than he could comfortably date. But the scope of what lay beneath the ground was beyond anything he imagined. It was not until the 1920s that the true scale of the discovery began to emerge. Between 1921 and 1922, two archaeologists working in different locations arrived independently at discoveries that would rewrite the history of South Asian civilization. At Harappa in Punjab, Dayyaram Sahni conducted systematic excavations and confirmed the presence of a large, organized ancient settlement with architecture and artifacts unlike anything previously recorded from the Indian subcontinent. At Mohenjo-Daro in Sindh, roughly 600 kilometers to the southwest, Rahul Das Banerjee uncovered the remains of an even larger city, a planned urban environment with brick streets, public buildings, and a degree of architectural organization that suggested something extraordinary. John Marshall, then Director General of the Archaeological Survey of India, coordinated the findings and in 1924 announced to the world what had been found. A civilization. An ancient, extensive, organized civilization occupying the Indus Valley and surrounding regions, predating the earliest known historical records from the Indian subcontinent by thousands of years. A civilization, Marshall wrote with visible astonishment, hitherto completely unknown. The announcement was not merely surprising, it was paradigm-shattering. At the time, the accepted understanding was that Indian civilization had its origins in the Vedic period, beginning roughly 1500 BCE, when Indo-European speaking peoples migrated into the subcontinent from the northwest. The discovery at Harappa and Mohenjo-Daro pushed the timeline back by more than 2,000 years. Here were cities, real cities, with all the infrastructure and organizational complexity that word implies, flourishing at the same time as the Old Kingdom of Egypt, as the early dynastic period of Mesopotamia, as the construction of Stonehenge. Here, in a river valley in what is now Pakistan and northwestern India, a civilization had risen, matured, and reached its peak between approximately 2600 and 1900 BCE. It had built cities, it had created art, it had developed writing, it had organized trade across enormous distances, and then it had disappeared so completely that its very existence had been forgotten. The rediscovery raised an immediate and obvious question. What happened to it? Part 2. What they built. Before confronting what was lost, it is necessary to understand what was there. Because the scale and sophistication of the Indus Valley Civilization is not always conveyed in popular accounts, and without understanding what existed, the magnitude of its disappearance cannot be properly appreciated. The civilization, at its peak, encompassed more than 1,000 known sites. Excavations and remote sensing surveys have identified settlements stretching from Balochistan in the west to the upper Ganges-Yamuna plain in the east, from the Himalayan foothills in the north to the coast of Gujarat in the south. The geographic extent is roughly equivalent to the combined area of France, Germany, and Spain. The urban centers within this area were not primitive settlements. They were engineered cities, built according to plans that reflect a level of organizational thinking rarely seen in any ancient civilization. Mohenjo-Daro, the largest of the known sites, covered an area of approximately 250 hectares at its peak. Estimates of its population range from 40,000 to over 80,000 people, a metropolis by ancient standards, comparable in scale to contemporary Ur in Mesopotamia or Memphis in Egypt. The city was built on an elevated platform to protect it from flooding, divided into a western citadel area containing large public buildings and an eastern lower city of residential and commercial neighborhoods arranged in a strict grid pattern. The streets of Mohenjo-Daro were laid out at right angles. They were wide enough for ox carts to pass. They were flanked by brick buildings, some of which stood 2 stories tall. The city had public wells at regular intervals, accessible to residents throughout the settlement. It had a large public bath, the Great Bath, as it is now called, a precisely constructed brick-lined pool measuring approximately 12 meters by 7 meters and nearly 2.5 meters deep, waterproofed with bitumen, fed by a well and equipped with drains and changing rooms. The purpose of the Great Bath is debated. Some researchers believe it had ritual or religious significance. Others suggest it served hygienic or civic functions. What is beyond debate is the sophistication of its construction. The sanitation infrastructure of Mohenjo-Daro is, by any measure, one of the most remarkable achievements of the ancient world. Nearly every residential building in the excavated areas was connected to a drainage system, a network of covered brick drains running beneath the streets, channeling wastewater and sewage away from living areas. Individual homes had dedicated washrooms with drains leading into the main drainage channels. Some houses had vertical chutes through which waste could be dropped directly into street-level drains from upper floors. The drains were built with inspection openings, suggesting planned maintenance. They were, in architectural terms, a functioning sewage system, something that most of Europe would not achieve again until the 19th century CE. The standardization observed across Indus sites is perhaps the most intellectually striking feature of the civilization. Bricks throughout the civilization, from Harappa to Mohenjo-Daro to smaller settlements hundreds of kilometers apart, were made to the same proportions. The ratio of thickness to width to length was consistently 1 to 2 to 4. This is not a coincidence. It reflects either a shared manufacturing tradition enforced across an enormous geographic area, or a centralized authority capable of implementing uniform standards across hundreds of settlements. The precise mechanism remains unknown. No royal palace has been identified at any Indus site. No unambiguous throne room, no clearly royal tomb, no monument dedicated to a named ruler. The civilization apparently organized itself without the kind of visible monument-erecting royal hierarchy that characterized Egypt or Mesopotamia. The weights and measures used across the civilization were similarly standardized. Excavations at dozens of sites have recovered small carved stone weights in a consistent binary ratio: 1, 2, 4, 8, 16, 32, 64, and a decimal progression for smaller denominations. These weights appear across the full geographic extent of the civilization. A merchant in Harappa used the same unit of weight as a merchant in Lothal, some 1,500 kilometers to the southeast on the coast of Gujarat. This is not the kind of consistency that emerges by accident. The craft production of the Indus civilization reached levels of refinement that continue to astonish specialists. Artisans produced carnelian beads of extraordinary quality. The long barrel-shaped harappan bead is found at sites across the ancient world, from Mesopotamia to Central Asia, and represents a manufacturing tradition that required controlled heating of the raw stone, precise drilling with hardened tools, and finishing processes that modern craftspeople have struggled to replicate. Pottery was produced on the wheel to a high standard of consistency. Bronze tools were cast in significant quantities. Faience, a glassy ceramic material, was produced in quantity and shaped into figurines, beads, and amulets of considerable artistic refinement. And then there is the writing. The Indus script is one of the most maddening unsolved puzzles in the entire history of human communication. Over 4,000 inscribed objects have been recovered, primarily small carved steatite seals, but also pottery, copper tablets, and bone objects. The inscriptions range from a single sign to over 24 signs. The script consists of between 400 and 700 distinct signs, depending on how they are counted and classified, a number that places it in the logographic range rather than purely alphabetic, suggesting each sign may represent a word, syllable, or concept rather than a single phoneme. Researchers have attempted to decipher the script for over 100 years. The effort has produced not a decipherment, but a catalogue of failed attempts. The Indus script has resisted every computational technique, every statistical approach, every comparative linguistic method applied to it. The reason is fundamental. Decipherment of an unknown script requires either a bilingual text, a Rosetta Stone, or a reasonable hypothesis about what language underlies the script. The Indus civilization has provided neither. No bilingual inscription has ever been found, and the language of the Indus people remains completely unknown. Proposed candidates range from an early form of Dravidian, the language family that includes Tamil, Telugu, and Kannada spoken across southern India today, to an early Indo-European language, to a language family that is now entirely extinct with no known living descendants. Each proposal has attracted both adherents and critics. Each has produced claim decipherments that other researchers have rejected. As of today, no consensus exists and the Indus script remains undeciphered. This means we cannot read what the Indus people wrote. We cannot read their administrative records if they had them. We cannot read their religious texts if they had them. We cannot read the names of their cities, the names of their rulers if there were rulers, the names of the goods their merchants traded. We cannot read the inscriptions on the seals they pressed into clay across thousands of kilometers of territory. The most abundant written record they left behind is, to us, completely opaque. This silence amplifies everything else we do not know. Part 3. The shape of the mystery. Between approximately 1900 and 1700 BCE, something changed. The large cities began to show signs of decline. The careful planning that had characterized Indus urban construction, the grid streets, the standardized bricks, the maintained drainage systems began to break down. At Mohenjo-Daro, excavations reveal a late period in which smaller, less carefully built structures were erected within the spaces of earlier, more organized architecture. The previously maintained drainage channels began to go uncleared. Formerly, public spaces were encroached upon by informal construction. The meticulous urban order that had defined the civilization for centuries was fraying. The standardization that had once linked settlements across 1.5 million square kilometers began to fragment. The uniform brick ratios became inconsistent. The standardized weights began to vary between regions. The craft traditions that had produced the distinctive long carnelian beads and the precisely engraved seals began to decline in quality and eventually to disappear. Trade with Mesopotamia, which is documented in Mesopotamian texts from the period of the Akkadian Empire onward, drops from the records around 1750 BCE and does not return. Mesopotamian references to Meluha, the name ancient Mesopotamians apparently used for the Indus region, become absent. The trade goods that had flowed along maritime routes through the Persian Gulf for centuries simply stop appearing in Mesopotamian excavation contexts. The settlements themselves began to empty, not all at once and not uniformly. This is one of the features of the decline that makes simple explanations difficult. Different sites show different trajectories. Some large cities appear to have been abandoned relatively quickly. Others show longer periods of declining occupation before eventual depopulation. Some regions within the broader Indus cultural sphere show population decline earlier than others. The eastern regions, including areas now in northwestern India, particularly along the dried bed of what was once the Gagahakra River, shows some evidence of continued occupation or even population increase in the late period, as if people were moving eastward even as western cities emptied. By approximately 1300 BCE, the large urban centers were gone. Mohenjo-Daro, which had been one of the greatest cities on earth, was abandoned. Harappa was abandoned. Dholavira, the remarkable city built on an island in the Rann of Kutch with its precisely engineered water storage system and monumental inscriptions, was abandoned. The smaller settlements that had formed the economic and social support network for these cities were largely abandoned. The population dispersed into smaller rural settlements, into regions outside the original Indus heartland, into an archaeological record of scattered, modest villages that bear faint traces of Indus cultural traditions but none of the urban complexity. The writing disappeared, not evolved into a successor script, disappeared. After the collapse, no inscriptions in the Indus script are found anywhere. There is no transitional period of simpler inscriptions, no evidence of the script being gradually replaced by a new system. It simply stops. Whatever purpose it served, whatever community maintained it, whatever institutional structure required it, all of that ended and the script ended with it. This is the mystery, not the simple fact of a civilization declining. Civilizations decline all the time for comprehensible reasons and leave behind comprehensible traces of their decline. The mystery is the totality of what disappeared, the speed with which it disappeared relative to the civilization's long duration and the completeness of the forgetting that followed. For nearly 4,000 years, the Indus Valley Civilization existed only as bricks beneath the soil. The question that has occupied archaeologists since the 1920s is why? Part 4. The Aryan Invasion Hypothesis. A century of controversy. The first and most dramatic explanation offered for the collapse of the Indus civilization has also been the most contentious, the most politically fraught, and, in its original form, the most thoroughly discredited. When John Marshall announced the discovery of Mohenjo-Daro and Harappa in 1924, the contemporaneous academic framework for understanding South Asian prehistory was shaped largely by the Vedic texts, the oldest religious literature of the Indian subcontinent, composed in an archaic form of Sanskrit and believed to record the arrival of Indo-European-speaking peoples, commonly called Aryans, from somewhere to the northwest. The Rig Veda, the oldest of these texts, contains hymns that reference battles, conquests, the destruction of cities called Puras, and the defeat of peoples who lived in walled settlements. It was, at first glance, a temptingly simple fit. Here were the walled settlements, here were the sophisticated cities, and here, apparently, was the date of their destruction, matching, roughly, the traditional dating of the Aryan migrations into the subcontinent. The most forceful proponent of this view was the British archaeologist Mortimer Wheeler, who excavated at Mohenjo-Daro in the 1940s and made an interpretation that became both famous and notorious. Wheeler found skeletons in the upper levels of Mohenjo-Daro, bodies in postures suggesting sudden, violent death, lying unburied in streets and buildings. He found what he interpreted as evidence of a massacre, and he attributed this massacre with considerable confidence to the invading Aryans. It may be, Wheeler wrote, that in the later Harappan period Indra stands accused. Indra, the Vedic god of war and storms, destroyer of cities, breaker of forts. Wheeler was suggesting that the hymns of the Rig Veda were a cultural memory of the actual destruction of Indus cities. The Aryans swept in from the northwest, sacked the cities, killed the inhabitants, and replaced the Indus civilization with the Vedic culture that would eventually give rise to classical Indian civilization. It was a dramatic narrative. It was also, subsequent research has demonstrated, largely wrong. The problems with Wheeler's interpretation accumulated over the following decades. Physical anthropologists re-examined the skeletons he identified as massacre victims and found that they represented deaths from a variety of causes over an extended period, not the bodies of a population cut down in a single military assault. The stratigraphy of the site, when more carefully analyzed, suggested that some of the massacre bodies predated the final abandonment of the city by a considerable margin. The postures Wheeler had interpreted as evidence of violent mass death could equally be explained as bodies of individuals who died from disease, from neglect, from the ordinary mortality of a declining and partially depopulated settlement. More fundamentally, the genetic and linguistic evidence for a simple catastrophic Aryan invasion of the kind Wheeler envisioned has not materialized. The picture that has emerged from decades of ancient DNA studies is considerably more complex. A story of migrations and admixtures occurring over long periods, not a sudden military conquest that could account for the overnight disappearance of urban civilization. And the dates don't fit. The major decline of the Indus urban centers begins around 1900 BCE. The dating of the early Rig Veda, while contested, is generally placed somewhat later. The cities were already emptying before the hypothesized invasion would have occurred. The Aryan invasion hypothesis, in its original aggressive form, has been largely abandoned by mainstream archaeology. What has replaced it is not a single clean answer, but a complex, still contested picture that draws on multiple disciplines and multiple lines of evidence, and that continues to generate significant disagreement. Part 5. The Climate Catastrophe. Hypothesis. If not conquest, then what? The hypothesis that has gained the most traction in recent decades points not to human invaders, but to a force more ancient and less discriminating: climate change. The Indus civilization was built on rivers. The Indus River itself, from which the civilization takes its name, is one of the longest rivers in Asia, fed by glacial melt from the Himalayas and carrying enormous volumes of water through an otherwise arid landscape. The civilization's cities were positioned to exploit river resources for agriculture, for transport, for water supply. The extraordinary wealth and organizational complexity of Harappan society rested ultimately on reliable access to water. For the civilization to function at its peak, supporting dense urban populations, maintaining intensive agriculture across an arid region, generating the agricultural surplus that made craft specialization and long-distance trade possible, the monsoon had to deliver. The evidence suggests that, at some point around 2000 BCE, it began to fail. The paleoclimate record for South Asia during the late 3rd millennium BCE shows clear signatures of aridification, a prolonged weakening of the summer monsoon that reduced rainfall across the Indus region over a period of centuries. This is not a local or disputed observation. Multiple independent proxy records, including lake sediments from Rajasthan, speleothem records from caves in Oman that reflect Indian Ocean moisture patterns, marine sediment cores from the Arabian Sea, and pollen records from sites across the region, all converge on the same conclusion. The monsoon weakened, rainfall declined, the region became drier. The consequences for an agricultural civilization dependent on seasonal rains would have been severe. Crop yields would have declined. The rivers, fed partly by monsoon runoff, as well as glacial melt, would have carried less water. The floodplains that Harappan farmers cultivated would have been less reliably inundated. The buffer between adequate food production and shortage would have narrowed, then disappeared. But the climate story is complicated by a second factor that may have been equally or more important. The Ghaggar-Hakra River. Running roughly parallel to the Indus but to the east, through what is now the Thar Desert of Rajasthan and the Punjab Plains, the Ghaggar-Hakra was once a substantial river, possibly one of the most significant rivers in the region. The dry bed of this river is lined with Indus sites. The density of archaeological settlements along its former course is, in fact, higher than along the Indus itself. This river once supported a significant portion of Harappan civilization, and sometime around or before 2000 BCE it dried up. The cause of the Ghaggar-Hakra's disappearance is itself a subject of fierce scientific debate. One influential theory holds that the river was fed partly by Himalayan glacial melt, and that a shift in the courses of Himalayan rivers, the Sutlej and the Yamuna specifically, caused those contributing tributaries to divert away from the Ghaggar-Hakra system, robbing it of much of its flow. River captures, the process by which one drainage system gradually captures the headwaters of another through erosion, are well documented in Himalayan geology. Whether such a capture occurred on the timescale relevant to the Indus collapse and what triggered it remains debated. Some researchers, including a team whose findings were published in the journal Nature in 2012, propose that the Ghaggar-Hakra was not a glacier-fed river at all during the Holocene, but a monsoon-fed river, and that its drying was a direct consequence of monsoon weakening rather than river capture. Others maintain that the geomorphological evidence supports the river capture model. The debate has not been resolved. What is not debated is the end result. The river dried up, and the settlements along its banks were abandoned. A 2012 study by researchers including Liviu Gheosan and Dorian Fuller, using satellite imagery, topographic data and fieldwork, mapped the full extent of Harappan settlement and its relationship to river systems. The findings supported a climate river model of collapse. The drying of the Ghaggar-Hakra system drove initial population displacement from the western and central regions of the civilization, while overall monsoon weakening undermined the agricultural foundations across the broader Indus zone. Significantly, the same study found evidence that the population did not simply die, it migrated. The archaeological record shows a proliferation of smaller settlements to the east and southeast in areas of Haryana, Uttar Pradesh and Gujarat during precisely the period when the large cities were declining. The Harappan population appears to have dispersed into smaller, more dispersed agricultural communities, abandoning the dense urban concentrations that depended on reliable water access. This is not a story of sudden catastrophe. It is a story of gradual, grinding environmental stress. A slow-motion disaster measured in drought years rather than battle days. But it does not explain everything. Part 6. What climate alone cannot explain. The climate hypothesis is compelling. The paleoclimate data is real. The correlation between monsoon weakening, river drying, and urban decline is supported by multiple independent lines of evidence. It is the leading explanation in current scholarship, and for good reasons. But several features of the Indus collapse sit awkwardly within a purely climate-driven framework. And these features are important because they suggest the story is more complex than a single cause, however powerful, can account for. The first problem is timing. The major aridification trend in South Asia during this period appears to have begun somewhere around 2200 to 2000 BCE. But the decline of the Indus cities, while beginning around 1900 BCE, was a prolonged process that extended across several centuries. Some sites show decline beginning earlier, some later. The pattern is not uniform. A simple drought killed the cities narrative would predict a more synchronous collapse across the region. What is observed is more gradual and more geographically variable. Moreover, the Indus civilization survived periods of climatic stress before. The Bronze Age world of the late 3rd millennium BCE was not climatically stable. There were earlier drought events, earlier flood cycles, earlier periods of reduced monsoon activity. The civilization weathered these. What was different about the aridification after 2000 BCE that made it fatal when earlier stresses were survivable? The question is not answered by simply demonstrating that a climate shift occurred. The second problem is the writing. Climate stress, even catastrophic climate stress, does not typically cause a writing system to disappear entirely and immediately. Writing is a technology. It persists through crises because it is useful for recording food inventories, for maintaining administrative records, for communicating across distance, precisely the situations most valuable during times of stress and social reorganization. When the Roman Empire collapsed in the West, Latin literacy declined but did not vanish overnight. When the late Bronze Age collapse devastated the Eastern Mediterranean around 1200 BCE, Linear B disappeared, but it reappeared in modified form as later Greek alphabets, and the underlying language survived. The Indus script left no descendants, no modified form, no gradual simplification into a successor system. It stopped. This is a very unusual feature for a writing system that was apparently in widespread use across a large civilization. It suggests not merely a reduction in population or an economic decline, but a complete collapse of whatever institutional or social structure maintained and transmitted the script. Whatever the Indus script was used for, whatever profession or class or institution depended on it, that entire social category ceased to exist. The third problem is the uniformity of what disappeared. The Indus civilization was remarkably uniform across its enormous geographic range. The standardized bricks, the standardized weights, the shared script, the consistent urban planning principles. This uniformity did not require obvious military or political coercion. No armies, no palaces, no obvious royal enforcement mechanism has been identified. It appears to have been maintained through some combination of shared cultural norms, economic interdependence, and perhaps religious authority. When the civilization collapsed, this uniformity collapsed completely and simultaneously. Not gradually, not regionally, but across the board. This is hard to explain through climate change alone, because climate change affects different regions differently. A drought along the Gagahakra would not necessarily destroy the standardized weight system at Dholavira on the coast of Gujarat or the craft traditions at Chanhudaro in Sindh. For the entire cultural superstructure of the civilization to dissolve simultaneously across such a large area, something must have disrupted the integrating mechanism itself, whatever it was that held this civilization together across 1.5 million square kilometers. And we do not know what that mechanism was. This is perhaps the deepest layer of the mystery. To explain how the Indus civilization ended, we would need to know how it worked, what held it together, what institutions maintained the uniformity, what social structures supported the cities and the trade and the writing. And those things, frustratingly, remain opaque. No palace has been found, no clear evidence of a temple hierarchy, no royal cemetery with elaborate grave goods marking the burial of rulers, no war monuments, no depicted battles, no named kings. The Indus civilization, uniquely among the great civilizations of antiquity, has not yielded a clear picture of its political structure. And without understanding the political structure, understanding the political collapse is nearly impossible. Part 7. Epidemic, Internal Collapse and Other Proposals. The climate hypothesis dominates current scholarship, but it shares space with other proposals, some of which have moved from the fringes toward greater respectability as new evidence accumulates, and some of which remain speculative. Epidemic disease is one of the less commonly discussed but potentially significant factors. Infectious disease in dense, interconnected urban populations was a recurring catastrophe throughout the ancient world. The connection between urban density and epidemic risk is direct and well documented. Cities bring people together in quantities that facilitate the transmission of pathogens, and trade networks extend the reach of infectious agents across enormous distances. The Indus civilization had both. Its cities were densely populated. Its trade networks linked settlements across 1.5 million square kilometers and connected via maritime routes to Mesopotamia and beyond. The conditions for epidemic spread were present. Whether epidemic disease played a role in the decline is difficult to assess archaeologically. Ancient pathogens leave traces in skeletal remains, but identifying them requires specific preservation conditions and careful forensic analysis. The skeletal record from Indus sites has been examined for evidence of disease-associated bone changes, with some researchers identifying indicators of chronic infectious disease in late-period populations. The evidence is suggestive but not conclusive. Some researchers have proposed that the Indus collapse reflects an internal social breakdown, a failure of the governing or integrating structure that maintained the civilization's cohesion. This hypothesis is difficult to test directly, but it is supported by analogy with other complex society collapses. Archaeological research on the collapse of Maya Classic period cities, the Mycenaean Greek collapse, and the late Bronze Age Eastern Mediterranean collapse all suggest that complex societies can become brittle in ways that are not immediately visible in the material record. A complex, highly interconnected system can appear stable until the moment it reaches a threshold, beyond which it rapidly disintegrates. In this view, the Indus civilization may have been more fragile than its physical achievements suggest. The very uniformity that appears as a strength, the shared standards, the shared script, the shared cultural norms maintained across a huge area, may have reflected a tightly coupled system in which disruption at any point propagated rapidly through the whole. Climate stress could have been the trigger. The actual collapse mechanism may have been internal, a failure of the social institutions that maintained integration when the environmental conditions supporting them began to deteriorate. There is also the possibility, increasingly discussed in recent literature, that the collapse was partly a deliberate transformation rather than an involuntary disintegration. Some researchers have noted that the dispersal of population from the Indus cities was not random. It moved in comprehensible directions, toward regions with different environmental characteristics, toward the east and southeast where different agricultural strategies were possible. This looks less like a panicked flight from catastrophe and more like a managed, if painful, relocation. In this reading, the abandonment of the cities was not purely a disaster that happened to the Indus people. It may have been, in part, a response, an adaptation to changing conditions. A population that recognized the large cities were no longer viable and dispersed into smaller, more resilient communities with lower resource demands and greater flexibility. This interpretation does not make the collapse less significant. Cities of 50,000 people becoming villages of a few hundred is a collapse by any definition. The writing disappearing is a collapse. The long-distance trade networks going silent is a collapse. But it suggests that the people themselves survived, that they adapted, transformed, and became the ancestors of later South Asian cultures, rather than simply being wiped out. The genetic evidence, which has expanded dramatically in the last decade through ancient DNA analysis, broadly supports this picture. Harappan genetic ancestry does not disappear from South Asia. It persists, mixed with later arriving genetic components in the populations of South Asia today. The people survived. What did not survive was the urban civilization they had built. Part 8. The Mohenjo-Daro Problem. Of all the specific archaeological puzzles generated by the Indus collapse, perhaps the most haunting is what happened at Mohenjo-Daro in its final phase. The city that had been one of the greatest urban centers on Earth in its prime shows, in its latest stratigraphic layers, a picture of dramatic decline. The previously maintained grid layout was violated. Poorly built structures crowded into formerly open spaces. The drainage system, once a marvel of ancient engineering, went uncleared and fell into disrepair. The population appears to have contracted into smaller and smaller areas of the site, abandoning peripheral neighborhoods while crowding into a shrinking core. And then, in those final layers, the skeletons. Mortimer Wheeler's massacre interpretation has been dismissed, but the skeletons themselves remain real. In the uppermost levels of Mohenjo-Daro, researchers have found the remains of people who died without proper burial, bodies in streets, in houses, in positions suggesting they were not interred according to whatever mortuary customs the civilization practiced. Some show signs of violence, some do not. Some are grouped together in ways that suggest they died in the same event or over a short period. The range of interpretations is wide. Disease outbreak, local violence, neglect during a period of extreme social stress, ritual behavior associated with the declining population's final occupation of the site. No single explanation accounts for all the observed features. What is clear is that the final occupation of Mohenjo-Daro was not a managed, orderly departure. Something happened there, something that left the dead unburied and the city empty. What that something was remains genuinely unknown. The site also presents a geological puzzle that bears on the collapse question. Mohenjo-Daro shows evidence of repeated flooding throughout its occupation, layers of silt deposited by Indus River. Inundations separate different construction phases in the archaeological record. The city was rebuilt multiple times after flood damage, the new construction always elevated above the previous level, the whole site gradually rising as layers of mud and rubble accumulated. Some researchers have proposed that increased flooding, perhaps reflecting changes in the Indus River's behavior, driven by upstream geological changes or by altered monsoon patterns, contributed to the city's decline, separate from or in addition to the general aridification trend. A city that was regularly rebuilt after flooding and that survived for centuries through this cycle may have eventually reached a threshold where the floods became too frequent, too severe, or too costly to recover from. Others have proposed tectonic activity as a contributing factor. The region sits near active fault systems, and evidence for ancient earthquake activity in the Indus region has been identified. Some researchers have suggested that tectonic uplift altered the course of local rivers, contributing to flooding in some areas and drying in others. The evidence for seismic activity is real. Its connection to the collapse remains speculative. The picture at Mohenjo-Daro is, in microcosm, the picture of the whole mystery. Multiple factors, multiple possible causes, limited ability to disentangle their relative contributions, and an absence of the kind of textual record that would allow us to hear the voices of the people who lived through it. Part 9. Dholavira and the Cities of the Edge. While Mohenjo-Daro and Harappa dominate popular accounts of the Indus civilization, the full range of what was built extends far beyond these two sites, and some of the outliers are among the most archaeologically remarkable. Dholavira, discovered in the 1960s and excavated intensively since the 1990s, occupies a rocky island in the Rann of Kutch in Gujarat, at the extreme southern margin of the Indus Cultural Zone. It was declared a UNESCO World Heritage Site in 2021, and its excavation has revealed a city that is, in some respects, more distinctive than either of the northern giants. Dholavira was built not on a floodplain, but on rocky terrain with no major river nearby. The city's water supply depended entirely on rainwater harvesting. To solve this problem, the Harappan engineers who built Dholavira created one of the most sophisticated water management systems of the ancient world, a network of large reservoirs, channels and storage tanks carved into the rock, designed to capture, store and distribute rainwater through a complex system of sluices and overflow channels. The system was capable of storing enormous volumes of water through the dry season, sustaining a substantial urban population in an environment that receives minimal and highly seasonal rainfall. The scale and engineering precision of the Dholavira water system is, by any standard, extraordinary. The site contains at least 16 reservoirs, some of massive size, interconnected by channels that directed water from one to the next as each filled. The capacity of the largest reservoir has been estimated at several 100,000 cubic meters. The system appears to have been maintained and expanded over centuries, with evidence of modifications and upgrades in multiple construction phases. Dholavira also produced one of the most intriguing single artifacts of the Indus civilization, a large wooden signboard apparently displayed above the entrance to the northern gateway of the city's citadel area, inscribed with 10 large Indus script signs made from pieces of crystalline rock. The sign was likely visible from a considerable distance. It is one of the few examples of monumental Indus script, the others being typically small, intimate objects like seals and tablets. What it said, no one knows. Dholavira shows decline beginning around 2100 to 2000 BCE, earlier than some other major centers. Researchers have suggested this may reflect a reduction in the monsoon rainfall that the city's entire water supply depended on, a more direct vulnerability than cities on major rivers. The reservoir system, ingenious as it was, could only store what the rains provided. When the rains weakened, the stored water shrank, and a city built in an already arid environment had less margin for error than one positioned on the Indus or the Gagahakra. The city was not continuously occupied through its entire history. Excavations reveal a phase of abandonment followed by reoccupation. The city emptied, was inhabited again by a smaller population, and eventually abandoned for good. This pattern of partial recovery, followed by final departure, is seen at other Indus sites as well, and suggests a population struggling to maintain urban life under increasingly difficult conditions rather than suffering a single catastrophic event. The trajectory of Dholavira illustrates what may be the most accurate framing of the Indus collapse overall. Not an overnight disappearance, despite how the mystery is sometimes characterized, but a long grinding process of stress, adaptation, partial recovery, and eventual defeat, the record of a sophisticated civilization doing everything it could to survive environmental conditions that had exceeded its capacity to compensate. Part 10. The people who did not disappear. One of the most important revisions in understanding of the Indus collapse, driven by the explosion of ancient DNA research over the past decade, concerns the fate of the people themselves. The early framing of the collapse, particularly in the versions associated with the invasion hypothesis, tended to imply that the Indus people were displaced, killed, or absorbed into a replacement population. The cities were destroyed. The culture was replaced. The people were, in one version or another, gone. The genetic evidence does not support this picture. Ancient DNA extracted from skeletal remains at Indus period sites and analyzed by multiple research teams, including a landmark study published in Science in 2019 by Vagish Narasimhan, David Reich and colleagues, reveals a picture of genetic continuity and mixture rather than replacement. The people buried at Indus period sites show genetic profiles that persist into later South Asian populations. They are the ancestors, in significant part, of hundreds of millions of people living in South Asia today. What the DNA studies also reveal is that the genetic makeup of South Asian populations began to shift after the Indus period, with the introduction of additional ancestry components associated with populations from the Eurasian steppe. This is consistent with migration from the northwest occurring after the urban phase of the Indus civilization, but it is not the invasion and replacement picture Wheeler imagined. It looks more like gradual admixture, the mixing of populations over time, rather than a military conquest that killed or expelled the original inhabitants. The Indus people survived. They did not maintain their urban civilization, their script, their long-distance trade networks, or their standardized manufacturing traditions, but they survived. They became farmers in smaller communities. They carried their genetic heritage forward into the populations that would eventually, centuries and millennia later, build new civilizations on the subcontinent. Civilizations that we can trace through archaeology and text into the historical period. This reframing matters for understanding the nature of the collapse. It was not genocide. It was not extinction. It was the dissolution of a complex social order, of the specific arrangements, institutions, and interconnections that had made urban life possible, without the elimination of the population that had participated in that order. The cities died. The civilization died. The people lived. And the question of why the specific institutional and cultural superstructure of the Indus civilization dissolved so completely, leaving so little trace in the successor cultures, with no writing surviving, no obvious memory preserved, remains open. Part 11. What modern technology has and has not revealed. The mystery of the Indus collapse is not, by any measure, a mystery for lack of effort. Since the initial discoveries of the 1920s, generations of archaeologists have worked to recover and interpret the physical remains of this civilization. In recent decades, that work has been augmented by an array of technologies that the early excavators could not have imagined. Satellite imagery and remote sensing have transformed the understanding of Indus settlement geography. Analysis of imagery from NASA's Shuttle Radar Topography mission and other sources has allowed researchers to map ancient river channels invisible at ground level, the buried courses of rivers that flowed thousands of years ago, tracing the distribution of Indus settlements against the hydrological landscape they depended on. This work has been essential to the climate river model of collapse, providing geographic context that no amount of ground excavation alone could supply. LiDAR, light detection and ranging, technology which uses laser pulses to create precise three-dimensional maps of terrain, has begun to be applied to Indus sites and surrounding landscapes. LiDAR has proven transformative in other archaeological contexts, revealing hidden structures beneath forest canopy or across vast areas that cannot be walked on foot. Its application to Indus archaeology is ongoing, with the potential to identify previously unknown sites and map known sites in far greater detail. Isotopic analysis has added biographical data to the skeletal record. The ratios of different isotopes of strontium, oxygen, and carbon preserved in bones and teeth carry information about where an individual lived and what they ate during different periods of life. Studies of Indus period burials have used isotopic data to identify migrants, people whose tooth enamel formed in childhood reflects a different geographic region than the site where they were buried as adults. The findings suggest significant mobility within the Indus world, people moving between settlements, potentially in response to economic opportunity, social networks, or environmental stress. Ancient DNA analysis, as discussed, has been transformative for understanding population history. The ability to sequence ancient genomes from skeletal remains and compare them to modern populations and to each other has produced a clearer picture of Indus population genetics than any previous method could provide. The technology continues to improve, and more ancient DNA studies from more Indus sites are underway. Each new dataset adds resolution to the picture of who the Indus people were and what happened to them genetically after the collapse. Computational climate modeling has integrated paleoclimate proxy data, the lake sediments, cave formations, marine cores, into dynamic models of ancient atmospheric and oceanic conditions. These models allow researchers to estimate what rainfall patterns would have looked like at specific times and locations during the late Harappan period, going beyond the simple observation that the monsoon weakened to attempt reconstruction of the specific agricultural consequences. Despite all of this, the fundamental mysteries remain. The script is undeciphered. The political structure is unknown. The mechanism of cultural integration, whatever held the civilization's remarkable uniformity together across such a large area, is not understood. The specific sequence of causes and consequences that produce the collapse, and the relative contribution of climate, social factors, and other variables is still debated. The tools have improved enormously. The answers have not fully arrived. Part 12. The comparative frame, the Indus collapse in context. The disappearance of the Indus civilization does not stand alone as an ancient historical mystery. It belongs to a broader pattern. The late 3rd and early 2nd millennium BCE was a period of widespread stress and collapse across multiple Bronze Age civilizations. Understanding this context does not dissolve the mystery, but it gives it important shape. The Akkadian Empire of Mesopotamia, the world's first empire by most definitions, collapsed around 2150 BCE after a prolonged drought reconstructed from multiple paleoclimate records. The collapse of the Old Kingdom in Egypt, around 2180 BCE, coincides with the same broader aridification event. The civilization of the Aegean in this period shows disruption and reorganization. The Late Bronze Age. Near East, several centuries later, underwent an even more dramatic and widespread collapse that destroyed or transformed nearly every major society, from Greece to Mesopotamia. This pattern has led some researchers to propose that there were civilization-scale climatic events in the late 3rd millennium BCE that exerted pressure across a broad geographic zone. A 4.2 kiloyear event, as it has been called in the paleoclimate literature, referring to a widespread aridification episode approximately 4,200 years before the present. Whether this event was a single coherent climatic phenomenon or a coincidence of regionally different stresses remains debated. Its correlation with multiple Bronze Age collapses is, however, striking. The Indus collapse, in this frame, is part of a larger story of Bronze Age civilizations encountering the limits of their resilience under climatic stress. The specific features of the Indus collapse, its totality, the disappearance of writing, the long geographic dispersal of population, reflect the specific character of Indus civilization and the specific environmental context of the Indus region. But the underlying dynamic may not be unique. This comparative context is relevant for a reason that goes beyond historical interest. Complex, integrated civilizations that span large geographic areas and depend on tightly coupled systems, environmental, economic, social, can reach thresholds beyond which collapse occurs with surprising speed. The stability that appears in the archaeological record across centuries can be misleading. Systems that have absorbed stress successfully for long periods may have fewer reserves than they appear to. A prolonged climate event that would have been manageable a century earlier may become fatal because the reserves have been quietly depleted. The Indus civilization lasted in its mature urban form for approximately 700 years, roughly the same duration as the classical Roman Empire from Augustus to the fall of the Western Empire. By the standards of ancient urban civilizations, that is not a brief existence, it is an impressive one. The collapse, when it came after centuries of successful adaptation to the challenges of maintaining urban life in an arid, seasonally variable environment. The civilization was not fragile, it was durable, but durability has limits, and the limits were reached. Part 13. The question of memory. One of the most haunting aspects of the Indus civilization's disappearance is not merely that the cities were abandoned, but that the memory of them was apparently lost. In most parts of the ancient world, the fall of a great civilization leaves traces in the cultural memory of successor peoples, in myths, in religious traditions, in the names of places, in garbled but persistent legends. The fall of Troy, whatever its historical basis, generated a literary tradition that survived for millennia. The destruction of Mesopotamian cities generated lamentations that were preserved in clay tablet libraries. The collapse of the Egyptian Old Kingdom is recorded in the texts of the First Intermediate Period. Even civilizations that fell to conquest left memories in the literary traditions of the conquerors. The Indus civilization appears to have left almost nothing in the cultural memory of its successors. The Vedic texts, the earliest literary record from the Indian subcontinent, do not appear to contain reliable memories of the Indus cities. Some researchers have attempted to read Vedic references to ancient battles and destroyed cities as garbled memories of Harappan times. But these interpretations require considerable interpretive latitude and have not achieved consensus. The Vedic texts are primarily concerned with religious ritual, with the social order of the peoples who composed them, and with the natural world as they experienced it, not with the ruins of a prior urban civilization. The gap between the end of the Indus urban period and the composition of the earliest Vedic texts is contested, but potentially several centuries. The people who composed the Rig Veda may not have had any direct knowledge of the Harappan cities, which had already been empty for generations by the time the Vedic tradition was taking shape. Or the Vedic tradition may have preserved fragments of Harappan cultural memory in forms that are no longer recognizable as such. We do not know. The undeciphered script means we cannot trace any intellectual or literary continuity from the Harappan world into the successor cultures. If the Indus people had creation myths, historical traditions, religious literature, or preserved memory of their civilization's origins, those things are locked inside a script that no one can read. This is perhaps the deepest loss. Not the cities. Cities can be rebuilt. Not the trade networks. Economies can be reconstructed. Not even the specific technologies, though their loss represents real human cost. The deepest loss is the voice. The Indus people had a writing system. They used it across a vast civilization for centuries. They wrote something, and we will never know what, unless the script is deciphered. Part 14. The possibility of decipherment. The undeciphered Indus script is not simply a historical curiosity. It is the lock on the most important door in the mystery. If the script could be read, we might have administrative records that illuminate the civilization's political structure. We might have religious texts that reveal its cosmology. We might have accounts of the decline, records made by people who were living through the collapse and attempting to understand what was happening to their world. Decipherment is not impossible. Linear B, the script used to write Mycenaean Greek, was undeciphered for half a century after the first tablets were discovered, and was finally cracked by Michael Ventris in 1952, using a combination of linguistic analysis and a crucial insight about the underlying language. Mayan script, long considered potentially undecipherable, was largely decoded in the second half of the 20th century through the cumulative work of many researchers, opening an entire literary tradition that had been invisible for centuries. The Indus script presents harder challenges than either of these. The corpus, while large in number of inscribed objects, is limited in the length of individual inscriptions. Most are very short. making statistical analysis of sign distribution and context difficult. The lack of a bilingual text is a severe obstacle, and the fundamental uncertainty about the underlying language means there is no phonetic framework to test proposed sign values against. The application of artificial intelligence and machine learning to the decipherment problem has attracted attention. Computational methods can identify patterns in large sign datasets, compare structural features of the Indus script to other ancient writing systems, and test statistical properties of the corpus against predictions from different linguistic hypotheses. Several research groups have published results of computational analyses. None has achieved decipherment, but the work continues. There is also the possibility of new archaeological discoveries. New sites are being identified. Existing sites still hold unexcavated deposits. The discovery of a new site with longer inscriptions, with a bilingual text, or with inscribed materials in a new context could provide the key that has so far been missing. Archaeological discovery is not systematic. It is partially controlled by where excavation resources are directed and partially determined by chance. The discovery that broke the Indus mystery open might be in a field in Pakistan that has not yet been surveyed. It might be in an already excavated site's unstudied storage boxes. The script remains undeciphered, but undeciphered is not the same as undecipherable. Part 15. Why this mystery still matters. There is a temptation when discussing ancient civilizations to treat their mysteries as purely academic questions, fascinating puzzles for specialists, but ultimately disconnected from the concerns of the present. The Indus Valley collapse resists this framing. A civilization of extraordinary sophistication, built over centuries, dependent on reliable water supply, integrated through shared cultural norms and economic networks across an enormous geographic area, and then undermined by a combination of climate change, environmental degradation, and the failure of the integrating institutions that held it together. The echoes of that pattern are not difficult to hear. The specifics are, of course, entirely different. Modern civilization has technologies and resources the Harappans could not have imagined. The mechanisms of contemporary climate change are different from Bronze Age monsoon variability. The institutions of the modern world, with all their flaws, are different from whatever the Indus people had. But the underlying dynamic, the possibility that complex, integrated, apparently stable civilizations can encounter thresholds beyond which rapid collapse occurs, is a lesson that the Indus collapse teaches with particular clarity, precisely because the civilization was so accomplished and so durable before the end came. The Harappans built indoor plumbing when most of the world was living without it. They standardized weights and measures to facilitate trade across a subcontinent-scale network. They managed water in an arid environment with an ingenuity that remains impressive. They maintained urban civilization for 7 centuries, and then they did not. Understanding why, understanding what failed, what proved to be the limit of adaptation, what pushed a durable system past the point of recovery, is not merely an exercise in historical curiosity. It is a study in the fragility of complexity, a reminder that sophisticated systems contain vulnerabilities that are not visible during stable periods, a demonstration that even populations that survive do so at a cost measured in the loss of everything their civilization had achieved. The Indus Valley Civilization was not a failed civilization. It was a successful civilization that eventually encountered conditions it could not overcome. That distinction matters. Failure implies inadequacy. The Harappans were not inadequate. They were faced with challenges, climatic, environmental, possibly internal, that exceeded the capacity of any civilization operating within the technological and institutional constraints of the Bronze Age. Epilogue. The nearest shore. Stand at the site of Mohenjo-Daro today in the Sindh province of Pakistan and look out over the low mounds that mark the ruins of streets and buildings. The excavated areas reveal brick walls emerging from the earth. The actual bricks, fired 4,000 years ago, mortared by hands that have been dust for longer than Rome has existed. In these walls, somewhere, is an answer. Perhaps in a deposit not yet excavated. Perhaps in an inscription not yet found. Perhaps in a layer of soil whose chemical composition will someday tell a story about rainfall and crop failure, and the terrible arithmetic of a population exceeding what a drying landscape could support. Or perhaps the answer is multiple answers, woven together in ways that will require decades more of careful, collaborative, interdisciplinary research to begin to separate. The Indus Valley Civilization lasted perhaps 1,000 years from its earliest urban phases to the final abandonment of its cities. It built, at its peak, something that can only be called magnificent. It engaged with the world on terms of trade and cultural exchange that connected it to the other great civilizations of its time. It developed writing, a technology so useful, so durable, that virtually every other civilization that developed it maintained it through collapse, invasion, and transformation. And then it was gone. So completely gone that 4,000 years passed before anyone knew it had existed. The discovery of 1924 was not the solution to a mystery. It was the opening of one. 100 years of archaeology, genetics, climate science, and computational analysis have narrowed the mystery considerably. We know far more about the Indus civilization and its collapse than Marshall or Wheeler could have imagined. But the mystery has not been solved. What we know is this: a great civilization rose in a river valley, built cities of astonishing sophistication, maintained remarkable uniformity across an enormous area for centuries, and then, under pressures that included climate change, river drying, and possibly internal stresses we do not fully understand, collapsed and dispersed. Its people survived. Its civilization did not. What we do not know is why the collapse was so complete, why the writing disappeared without descendants, what institutions held the civilization together, and what caused them to dissolve, and what the people who lived through the decline experienced and thought and recorded in a script that no one alive today can read. The nearest shore of that mystery is visible from where we stand. The tools for reaching it are better than they have ever been. But the shore is still across water we have not fully learned to cross, and in the silence left by an undeciphered script, 4,000 years of lost voices wait. If you found this deep dive into one of history's greatest unsolved mysteries compelling, consider subscribing and sharing. The story of what we do not know is often more important than what we do. And the Indus Valley is one of the places where that gap is widest and deepest and most worth exploring.